Hello students, welcome to the channel Chemistry is Fun. In today's video, we're going to learn about how to calculate sigma and pi bonds in a given organic compound. So sigma, this is the symbol for sigma bond and this is the symbol for pi bond. Okay, sigma bond is usually stronger than pi bond. That means sigma bond can exist independently. Whenever you find two atoms and in between there's a single line, that means it is a sigma bond. But whenever you find a double line between the two atoms, then that means it's a double bond where one is sigma, one is pi. Okay, sigma remains as a support to the pi. Pi cannot exist independently, but whereas sigma can exist independently. So whenever you find a single bond, it has to be a sigma bond. Whenever there's a double bond, one is sigma, one is pi. Whenever there is triple bond, there should be one sigma and the remaining have to be 2 pi. Okay, so sigma bond can exist independently, pi bond cannot exist independently. There can be only one sigma between two atoms and the remaining has to be pi electrons. And moreover, between any two atoms, the maximum number of bonds possible is equal to only 3. Okay, so since we are talking about the calculation of sigma and pi in the case of organic compounds, the most common organic compounds that we come across is hydrocarbons, that is alkanes. Okay, so let us know the formula to find out sigma bonds in case of alkanes. Okay, so the formula is total number of carbon atoms into 3 plus 1. Okay, so when a simple carbon atom is given to carbon molecule is given to you like methane, we can easily write the structure or draw the bonds and find out. For example, in case of methane, total number of carbon atoms is only 1. Sorry, total number of carbon atoms is only equal to 1 plus 1 into 3 plus 1. So it's equal to 4. That means there are 4 sigma bonds in the methane molecule. So such simple molecules we can draw the structure and find out the number of bonds. But if at all a large compound is given to you like C100 H102, sorry, H202. When a large molecule like this is given, you cannot go on write C until 100 and write the bonds around it. It's a hectic process. So instead we can use this simple uh, formula to find out the number of sigma bonds. So how many carbon atoms there in this? There are 100 carbon atoms into 3 plus 1. So which is equal to how much? 300 plus 1, which is equal to 301. That means there are 301 sigma bonds in this C100 molecule. If you want to check it out, you can just try like drawing the structure completely. Okay, so this is a simple method to find out the number of sigma bonds. Similarly, in case of alkenes, by the way, what is the general formula of alkanes? It is CnH2n plus 2. Okay, alkenes have a general formula of CnH2n. Okay, for them, the formula will be total number of carbon atoms into 3 minus 1. Instead of 3 plus 1, we write 3 minus 1. Total carbon atoms into 3 minus 1 you have to do. Only this is the difference between alkanes and alkenes. Now, take an example. Let's take an example of ethylene here. CH2, CH2. So the number of carbon atoms are here 2 into 3 minus 1. So how much is it? 2 into 3, 6 minus 1 is 5. So there are 5 sigma bonds in the case of ethylene. Now let's take a large molecule C100 H200, which is equal to how much? 100 into 3 minus 1. So which is 300 minus 1, 299 sigma bonds are there in this molecule. Similarly, when you try to calculate in the alkynes, whose general formula is CN, sorry, whose general formula is CnH2n minus 2. Okay, CnH2n minus 2 is the general formula. Now for them, the formula could be, you can guess it by this time. So total carbon atoms is into 3 minus 3. Okay, total carbon atoms into 3 minus 3. So let's take an example which is CH3, CH2, CH2, C triple bond CH. Now in this molecule there are 1, 2, 3, 4, 5 carbon atoms. So 5 into 3 minus 3. 5 into 3 minus 3 is 0, into 5 is 0, don't count like that. 5 into 3 is 15 minus 3 equal to 12, you should get the answer. Okay. Similarly, if you take any large molecule like this, C100 H198, if you take, you get 100 into 3 minus 3. So it's 300 minus 3, we get 297. So this way we calculate the number of sigma bonds in case of alkenes, alkenes and alkynes by a simple. Let us look at the calculation of pi bonds in organic compounds. So the formula for calculating the pi bonds is total number of pi bonds is equal to 2n plus 2 minus total number of hydrogens by 2. So where n, what is n here? N is nothing but the number of carbon atoms in the hydrocarbon. Now n is equal to carbon atoms present in the hydrocarbon. So let's take an example and look at the formula if it is working. So we have C4H8, which is an alkene. Okay, so 2 into carbon atoms are equal to 4. So 2 into 4 plus 2 minus hydrogen atoms are 8 by 2. So how much is this? 8 plus 2, 10 minus 8. 10 minus 8 is 2, 2 by 2 is 1. So that means in C4H8 molecule, you find only one pi bond. That means this is an alkene. Okay. Similarly, you can take a look at another formula which is C4H6. So let's try to find out how many pi bonds are present in this. So apply the same formula, 2 into 4. Okay, if carbon atoms are 4, 2 into 4 plus 2 minus hydrogen atoms are 6 by 2. So 2 into 4 is 8 plus 2 is 10. 10 minus 6 is 4. 4 by 2 is 2. So that means there are 2 pi bonds in this molecule. So this can be the example for a diene. Okay. And this is an example of ene molecule. This is a single uh, one double bond is present in C4H8 and two double bonds are present in C4H6. Similarly, you can apply the formula for any number of carbon atoms present in the hydrocarbon. Hope this video is useful to you. Thank you.